Welcome, grade 12s. Okay, so we'll be dealing with question 2 of our review of the November 2023 mathematics paper 1. Okay, so now in this case, we're given an arithmetic series made up of the values 7, 12, and 17. Now, just want to make a quick note here. Whenever you're dealing with a series, this would be the addition of the terms made by an arithmetic pattern. Okay, but whenever you're dealing with an arithmetic series, remember that all the information that you have learned when it comes to an arithmetic pattern still applies. So this means that I can still find the general solution or the nth term of this pattern. Okay, so whatever you could do to an arithmetic pattern, you can still do to an arithmetic series. Now, in this case, what's different is that you can also find the sum of the values that make up that pattern. So that's the only difference that we get. Okay, so let us go into it here. So 2.1.1, they're saying determine the value of T91. So now they're saying that we want the value of term 91. So instead of treating it like a series, the addition of the terms here, we can just take a perspective of a pattern, okay? Because this means that we just look at the pattern itself rather than it being a series, because we're not adding up the terms to get the term 91. Okay, so for this solution right there, what we're going to do is we're going to say, well, for 2.2.1, we are looking for term 91. So we're going to take it as an arithmetic pattern like that, as we should, because it is. So now what's the first value there? We get 7. And now we are dealing with position 91. Position 91. So wherever there's n in this case, we're going to say 91 plus 1. And now what's the difference? Well, remember that we had T2 as 12 and T1 as 7. So the difference here should be a 5. Okay. So now we have a 91 minus 1, which is 90. 90 multiplied by 5, giving us 450. Add a 7 to it, you get 457. Okay. So now whenever you're dealing with a term like this, when you're dealing with a pattern, you know that n represents position. In this case, we know that n represents position. N is the position. This is when you are looking at the pattern itself. And you will see that it will be a bit different when we're tackling the sum. Okay, so in this case, they said that they're looking for S91, right? That would be the second question that we had up there. Okay, so now whenever they're saying that they're looking for S91, they're looking for the sum of the first 91 terms, all right? So it means that whenever you're dealing with the sum, this is the number of terms that you'll be adding up together to get that sum. Okay. So now in this case, we've been told that this is arithmetic. So we know that we have n over 2 into 2a plus n minus 1 multiplied with the difference. So now we don't have to calculate a. We know it, it's 7. And we don't have to calculate d again. We know it, it's 5 from the previous question. So the only thing that we have to do is do our correct substitution. So now in this case, this 91 does not represent position anymore, but it represents the number of terms you are adding up together. Okay, so we have 91 over 2 into 2 multiplied by 7. Now again, you have 91 minus 1, 5, close like that. And when you punch your calculator, you should get 21112, like that. So now in this case, n is the number of terms. N is the number of terms that we're adding up together, just in this case. So these would be the differences that you and I have to take care of when we're solving these questions. Okay, let's go on. We have 2.1.3 down here. So let's go back to our question up there. Now they say calculate the value of n. So now for which t of n is 517. Okay. So now this n here, will it be the position or will it be the number of terms? Well, we are guided by this guy here. Right? So now in the case where they're saying t of n, they're saying term of n. Okay? So meaning that in this case, this right here is position. So this is position. Okay. So it means that we're going to use the information of a pattern, or the equation of a pattern rather, to solve. So here we're going to say, well, we're going to look for t of n, which gives us 517. Now let's develop the equation for t of n. We know that it will be 7 plus. Now we're looking for that n minus 1 multiplied by the difference, which is 5 again. And that should give us how much? 17. So now we're looking for the position, right, of this term that gives us a value of 570. So take this guy to that side. We have n minus 1, 5 equals to 517 minus 7. And then now you can quickly divide both sides by 5 like that. Okay. Right, let's go a bit down. And what you're going to get here is that you have 517 minus 7, that will be 510. Now divide that by 5, you should be getting a value of 102. So you have n minus 1 this side because this should remove that. Then take this guy to that side. Now n is equals to 103, like that. So if they were looking for the number of terms, all right, that would give you, or the number of terms, I'm just thinking if this was the last term, right? If they say that this is the last term and they're asking for the number of terms, then we would then have to conclude that there are 103 terms in the pattern if this guy here was their last term. But in this case, it's not, and they're just looking for the value of n like that. So that's how we would go about the question. Excellent. Now let's keep it moving. Do we have another one? Nope. So let's move on to 2.2. Now they're saying the following information given about a quadratic number pattern. First term, 3. Then now they're giving us differences in this case. T2 minus T1 gives us 9. T3 minus T2 gives us 21, like that. Okay, so now what I want you to remember is that the first difference when it comes to a quadratic pattern, the first difference of a quadratic pattern is an arithmetic pattern. And the second difference of a quadratic pattern is just a constant difference, right? Because every arithmetic pattern produces a constant difference like that. Okay. So now their first question up here was to show that T5 is equal to 111. Okay, so I believe that there are two ways to do this. First way is, well, developing a diagram. And the second way is when you just want to show off. When you know the math, well, what can they say? They can't say anything. So now let's just develop the math here, the easy stuff. Let's start with the easy stuff, right? So we've been given that T1, let me just write them up here, T1, T2, T3, T4, and we just want to get to T5 and show that, we want to show that T5 is equals to 111. Okay, so we've been given this information that T1 is equal to 3. And the difference, remember that it would write the difference down here. When you say T2 minus T1, it should give us how much up there? I think they said 9. I believe the value that they gave up there was just 9. So let me just go up there again, sorry. So that's just 9, and the other value is 21. Yes. Okay. So it means that the first value of the arithmetic pattern, remember that this guy up here is your quadratic, and this guy down here, this will be your arithmetic, okay? And whatever we're going to have down here, that will be our constant, okay? So let me just have those like that, okay? So now for us to find our T2, we just have to add these values up, and this should give us how much? A 12, right? And they told us that T3 minus T2 should give us a value of 21 like that. So it means that when I add these two up, I should get a value of T3, which is going to be 33 when you add up together. Now let's go to our constant difference so that we can add this up down here so that we can go back up like that. So 21 minus that should give you 12. So it means that we'll be adding by 12 to get the next value. So 21 plus 12 again, we get 33. And now you can say 33 plus 33 to get the next guy, which would be 66 like that. Okay. And then you add another 12 down here, and that should give you a value of 45. And now when you say 66 plus 45, that should give you your value of how much? Of 111. And boom, we have it. We have it. We have shown that T5 is equals to 111. We're successful. We're successful in that regard. Okay. And we also have another fancy way that I was thinking about, right? When you just want to show off. It's not necessary for you to show off. Just write something that's simple and move on, okay? Sometimes you'll be stuck in your own complicated work, and then you will be worried, what were you trying to do here as a student? Okay, so let me write this in a different color. Maybe let's just say blue like that, okay? Hopefully this blue will be visible enough, okay? So remember that for your quadratic, T1 is equals to 3, like that, right? And we can develop an arithmetic quickly. We don't need to develop too much. We know that A for the arithmetic is 9. We've been given that piece of information before, right? And we know that the difference is how much? The difference is 12. Easy. When you say T2 minus T1, you get that 12 there because you've been given. You could solve for T2, then find the difference quickly, like that. You're right. Now, I want to tell you here, we've been adding up these terms, right? We've been adding up these terms. This means that we have added all these values here, all these values. We added these numbers to this number here to end up with that guy there. Because we kept on adding, isn't it? We kept on adding, right? So now this means that if I take the sum of these 4 numbers and add it to the first term, I will eventually get where? To T5, which is that 111 right there. Okay. So now, how many terms did I add to get to T5? I added all the other terms that came before it. And how many terms were those? Those were 4. So now we could say S4, so the sum of 4 terms of the arithmetic pattern plus T1 of the quadratic number pattern should give us T5. But we're going to do it step by step. So how many terms are we adding up together in total? 4 over 2 into 2. Right. Now, what's the first term that you're going to take? You're going to take the one of the arithmetic pattern, which is 9 in this case. So we're going to multiply by 9. Add. How many terms are we adding up? 4 minus 1 multiplied by. What is the difference there? You got 12, close like that. Punch this into your calculator. You quickly get a 108. Okay, so this means that when I add up 9, 21, up to 45 here, I'm going to get 108. So now when I say T5 is equals to T1 plus S4 of the arithmetic series there, look at this beauty here. Look at this beauty. 3 plus 108 indeed gives you 111. Boom. My goodness. So here you relied on the fact that you know what you're doing, okay? So again, if this is too fancy, please let's stick to the method that is shown above, right? But then you can always flex a little muscle when you got it. All right, let us move on to the second question, which is 2.2. Right, excellent. So 2.2.2. Okay, so now in 2.2, they say that, let's just quickly go back up to them. Let's just quickly go back up to them. Just to check the question. Now they say, show that the general term of the quadratic pattern is given by that information. Okay, so now in most cases, you'll see that whenever they want you to find the equation that governs the pattern, they will use keywords such as general term, or they could use nth term. Okay, so don't be confused by this language. Once you know that they're talking about the general term, they just want the equation of the pattern. When they're talking about the nth term, they want the equation of the pattern there. So don't be confused by this type of language, because this is how we're going to bag marks, all right? If you cannot understand the question, it won't be easy to even attempt it. I think you won't be able to give an adequate or a good answer to that. Okay, so now let's use the information above to solve for the values of A, B, and C. Then I'll just choose a different pen for now. Okay, so now whenever we want to solve for A, remember that we're going to say 2A is equal to the first value of the constant difference. There's a reason why I am going to say the first value of, even though the values are the same, okay? This is because I just want to smack it into your brains that you remember what we're going to be thinking about. And then you're going to do this for this equation here. Let me just remove this part. Okay, right. Now, whenever we want to solve for B, we're going to say 3A plus B is equal to the first value of the first difference, okay, which is in this case 9. And when we want to solve for C, we're going to say A plus B plus C is equal to the first value of the given quadratic pattern itself. So we're going to go in this manner. Now, whenever you solve, well, the easiest to solve here is A. Then you substitute the value of A into the second equation to solve for B. Then you substitute the values of A, B in the third equation to solve for C. So hopefully you guys get the idea here. So let's do that. We said that we have 2A is equals to 12. we have 3a plus b, which is going to be equal to 9. And we have a plus b plus c, which is equal to 3, like that. So we see that a is going to be equal to 6. So because we're dividing both sides by 2, then now we can take that value in here. 6 plus b is equals to 9. So this is 18. So we know that b is going to be 9 minus 18, which gives us negative 9, like that. So the value of b is negative 9. You can say therefore here. And here we have the value of 6 minus 9 plus c equals to 3. So this is going to be negative 3 plus c, giving us another 3. So when you transpose this negative 3 to the other side, when you just transpose it, this should give us a 6, like that. So therefore, the equation that we're going to have would be, it would be 6n squared plus, not plus, it should be negative. So minus 9 plus 6. Remember that we had to fill in the missing. So this is Tn is equals to an squared plus bn plus c, where we had to find a, b, and c. And now in this case, we have shown that. Right. Let us go on. What is the final question that we have here? I believe we have, that would be the final question after this one. Yeah, 2.2.3. They say, show that the pattern is increasing for all n is an element of natural numbers. Natural numbers. Remember that your natural numbers are whole positive numbers that start from 1. Okay. So now they are saying that from the beginning, just show that it will always be increasing. Now, whenever you have something of this nature, I want you to link it to everything you have studied, right? When you're looking at a pattern like this, and they're telling you that it's a quadratic pattern, another view that I want you to have, another point of view, another pause, right, is that this is a function. This is a parabola, right? So now, whenever they're speaking about increasing, decreasing, where it's positive, where it's negative, I want you to think about all the information or link this information to a parabola so that you are able to visualize what's happening, so that maybe it gives a clue on how to tackle the question that you'll be looking at in that moment. Right. So now, since I've said that, I believe that we can go on and try and solve this question. So I have 2 ways which are similar in this case, but then I'll just show both of them and we'll see which one is easy for you to live with or easy for you to understand. Okay. So now, first of all, what I'm going to do here is I'm going to draw or sketch, just give a sketch of what's happening. Okay. So I'm going to treat that as a parabola. Right. And so after testing all these values here, I saw that the function looks something like this. The function does not have roots. Okay. The function does not have roots. Okay. Now, let us begin. Let us begin discussing this information. One thing we understand is that if I am dealing with a function, then I know that you can have negative values and positive values, right? But in this for position on the x-axis here, on the x-axis, if I'm dealing with a function, right, I could have negative values and positive values. If it's just a normal function, right? But then whenever it comes to number patterns, we know that we won't consider the negative values because we do not have such a thing as negative position. Okay? We do not have such a thing as negative position. So we'd only consider the parts which are right of 0, like that, going to the other side. Okay. So now I'm just going to leave it as a function for now, for the purposes of explaining both methods that I want to utilize or show or share with you guys. Okay. So now what I want to think of this as is I want to think of derivatives. I want to think of derivatives, right? Because if I can get the gradient of the function at any point along the function, then I could use the words such as increasing, decreasing, right? Or remains the same. So one thing I know is that since the function is decreasing this side, right? When we read the function, we know that we read it from left to right. And we see that the function is a decreasing function. And for that matter, it would be linked to what? To negative gradient. The tangent would have negative gradient. Okay? And now, right here at this point, at the turning point, we know that the turning point is associated with a gradient of 0, because at that point, the function is neither increasing or decreasing. And then on the right of this function here, this function would be associated with positive what? Positive gradient, like that. Okay. So now someone is going to ask, how are we then going to solve this question? And that would be a very good question to ask. Okay. Now, I could say let f of x, right, f of x be a function such that it takes on the same behavior as our number pattern up there. But then it won't be limited where you could have negative numbers, positive numbers. Remember that you could also have values such as fractions. Whereas with a pattern, a number pattern, you cannot have position being what? Being a fraction, isn't it? Because you cannot have a position of 1,5. Just imagine when they say you've won a race and you came up 1,5. It wouldn't make sense. But then in this case, when I have a function, right, that can model the same behavior as this, maybe I could extract some information from it. And then I can go back and compare it with T of n here, the number pattern. So this would be 6x squared minus 9x plus 6, like that. Okay. So now what will I do here? What will I do? Well, let me just allow this to be x for now. And let me allow this to be f of x. So here, I know that my pattern starts at 1, right? My pattern starts at 1. For n equals to 1, I know that T of 1 is going to give me 7, right? My pattern starts at 1, right? And that first value here, Tn, will be 7. So now I want to find out where will I find these, right? Are they on the side where the function is decreasing? Or are they on the side where the function is increasing, right? So it means that right here for this value of x, which is x of TP, x value of the turning point, okay? If if this value x of TP is greater than 1, if this value x of TP is greater than 1, it means that parts of my pattern would start where? From the decreasing part, right? Maybe somewhere here. And then it means that after decreasing, there would be 0, then it would increase again. This is if x of TP is greater than 1. But then if x of TP is less than 1, it means that it happens before. So meaning that if there's a 1 somewhere up here, then the 1 would produce the 7, right? So it means that those parts would contain the pattern. And you would see that the pattern would be on the forever increasing side. Well, now let's find out what x of TP is, or the x value of the turning point. So now x of TP is governed by negative b over 2a. Please allow me to call this x of TP, x value of the turning point. It's easier when you're thinking about it that way. So this would be negative into negative 9 over 2 into 6, and this should give us 3 over 4. Boom. We see that x of TP is smaller than 1. So meaning that 1 is somewhere this side, right? And we know that our pattern here is formed by what? Discrete whole numbers. So probably 1 here, this value here would correspond to 2, that value would correspond to 3, that value maybe might correspond to a 4, and so on and so forth. If you're looking at the values of what? Of n. Okay, so now Tn, right? Tn is a subset of f of x. Tn is a subset of f of x, where this function, this function of t of n is found on the increasing side, Okay, so now how would we phrase that now to someone who understands mathematics or someone who's marking for us at the center? Okay, so we can say, well, for f of the derivative 3 over 4, that gives us 0, right? So we're showing that that's the turning point. Or someone else could say, well, the derivative is equals to 0 for x is equals to what? 3 over 4. Okay, so what does this mean? It means that the derivative is greater than 0 for x greater than what? 3 over 4. So now, since we know that n will always be a number greater than what? Greater than 0, meaning that it's going to be 1, 2, 3, right? And this number is greater than that. So we can say now T of n is increasing for all n. Okay. So, well, what can we say here? Yeah, for all n, an element of natural numbers like that. As n will always be a number greater than what? Than 3 over 4. N will always be a number greater than 3 over 4. So that's a line of thought that we can use here, right? Surely this could be cleaned up in a much more nicer way. Surely this could be cleaned up in a much more nicer way. But then that's the line of thought that we can produce here. And yeah, we would have shown. Okay. Now, the second method, which I feel like is a bit more refined, then this one here is, well, let's just take T of n as it is. So this is method number 2 here, where this was method number 1, right? Again, I'll be using the idea of a derivative. So we have 6n squared minus 9n plus 6. And I could find the derivative of this function, and this will give me minus 9 like that, right? And now I can test it. I can test it at the beginning, where what's happening, or what's the gradient? What's the gradient of the function when n is 1, right? When n is 1. I want to find out, because that's the starting point of the pattern, isn't it? So now I want to find out if the gradient is positive. I know that since this is a parabola, if that part is positive, then going forward, it must remain positive, isn't it? Because for a parabola, we know that a parabola where a is greater than 0, we know that it starts with being a decreasing function. Then it has a turning point. Then after that, the gradient must be positive. So if I find that the gradient is positive for this guy for n equals to 1, then it means that going forward, it must remain that. Okay, because it won't change anymore. Okay, so now we're going to test. Now, when n is 1, what is the value there? Then we have that. And we find that the gradient is positive. So now, which is what is positive here? Okay, that's positive. So what are we going to say here? Well, now we can say that, well, the gradient of the function, right? Remember that natural numbers start from 1. T of n is greater than 0 for n is an element of natural numbers. Therefore, T of n is greater than, well, we can just say it's increasing. Let me just put it like that, instead of just saying greater than 0. Like that. And this one is much more refined, easier to see and easier to follow. So that is it for question 2. Stick around and let's do more of the same for this document. More uploads will be coming on soon, and we'll see you there. Cheers.